Let's solve a jump camp 2 problem today. If you have not watched the video for jump camp 1, you can go and search that video in my channel and you can find that. And that will be helpful to understand this also. So anyway, first we'll understand jump camp 2 problem, and then we'll talk about this algorithm that's called greedy algorithm, and we can write the code that. So in this problem, if you see here, uh, we have given the array and we need to find out the the minimum jump to reach to the end. So like if you see 2 here, that means this from here we can jump max 2. We can jump to max here 1, and then from here again we can jump like 1. So this is it's a 1, so we can jump here 1, and then from 1 again we can jump one more time, so we can come here. So it takes multiple steps, but so this is saying like we can jump 2 max, and this says okay we can jump 3 max. So it doesn't mean we cannot jump 1. Of course we can jump 1 also. If you see 2, then you can jump 1, or I can jump to this place 2. If this 3, I can max jump 1 2 3 this place 4, or I can jump 1 also, or I can jump 2 also. So we need to try all these combinations, and we need to find out what's the minimum jump required to reach to end from like from this beginning. So that's the minimum jump we need to find out. So there can be multiple ways to solve this. We can try all these possible ways through dynamic approach. So that's also we can do that way. That's also, but today we are going to solve this using the greedy approach. And in this greedy approach, what we do, we just run a loop from here, and from here from beginning, and then we try to jump max. If 2, then we'll jump max. Actually the solution is here, if you try to jump here max, that's not a good way, because 2 max here, and then there's one step, and from 1 to 1 here 2 step, and 1 to here again, yeah, 3 steps. But if I jump from here to 1 step, it's 3, 1 step, and then after that if I make a max jump 3, 1 to 3 here, then it will be 2 jump. In a 2 jump we can reach to end. So so to try with this greedy approach, we need to have 2 points in the algorithm. One is, once we run the loop, then we try to jump the most farthest, and also we maintain the current farthest. So the current farthest is something like when we iterate this and we trace, and this index is like when the index is equal to the current farthest. In that case we can reset current farthest to the uh, like farthest one, most farthest one. So those logic we need to write, and that's a very easy. So we can just write, it's a few lines of code for this greedy jump. So let me write for, I can say I 0 I less than length of nums -1. We do not have to iterate till like length nums. We need to have the -1, because when iteration which goes through this iteration uh, will reach to the end, and like from end we do not want to proceed further. So before that we just want to end those things. So that's a plus plus here, and then I can have some variable, like let's say the farthest, how long I can jump here, and just initialize with 0, and then current farthest, that's all initialized with 0. And then another one is you can just say count. So count is 0. So here what I do, I will jump the maximum what I can here. So in this case I can just say here like if this farthest, just say this I0, like from here, uh, I plus, and if I jump maximum to, then it's nums2, that is nums I is greater than farthest, and of course farthest is in the beginning is 0, it's greater than 0, then farthest equal to I plus nums I. So that's exactly this I is a I is 0 in the beginning, and then nums I, so nums I, so if I make a 2, 0, 1, 2 here, so that's I count, and that's the farthest one. So in this way I can maintain the farthest one. And the current farthest, if I can have one more condition, if I equal to current farthest, so this is the time I can make a count plus plus this count, and also I reset current farthest to this farthest one. So that's all, and that's the two logic we need to maintain jump farthest one, and then check this condition, and then return jump. Let's check for any error. So count, jump count or count, just say just jump, jump count. Accepted, submit. That's a simple logic you can easily write in a Java also. So yeah, that's all for now. Thank you.